Hello there. In this video, we shall take a look at how to handle the chain rule for epicalculus derivative problems. We shall learn the single layer problems, the trig with angle layer problems, and the multi-layer derivative problems. Stay tuned. So with us here, we have three sets of problems we're going to tackle today. And the first problem is going to test our ability to handle the single layer trap, with the second testing our ability to handle the trig and angle chain trap, and the third challenge testing our ability to tackle multi-layered traps. So let's begin. We have the problem y equals 5x minus 2 power 4. So because we're dealing with a composite function, we need to use the chain rule. And the chain rule mandates that we find the derivative of the outer function and multiply with the derivative of the inner function without making any changes to the inner function. So we're going to use the power rule on the outer function, and it's going to give us this. And then we're going to find the derivative of the inner function. That is going to give us 1 multiplied 5x to the power 0 minus 0, which is the same as 1 multiplied 5 minus 0, which is the same as 5. So we're going to multiply 5 with the derivative of the outer function, which is 4, without making any changes to the inner function. That is going to give us the final answer of 5x minus 2 to the power 3. Then we're going to move on to the trig and angle chain trap. For this one, we have the problem y equals sin x to the power 2. Now this is not a plain variable, okay? We can see we have the exponent 2. So we cannot just conclude that the derivative of this function is going to be cos x squared, because that is going to be wrong. To tackle this problem, we need to find the derivative of the outer function and multiply with the derivative of the inner function without making changes to the inner function, similar to what we did in the single layer trap section. So that is going to give us cos x squared multiplied the derivative of the inner function, which is 2. 2 comes down, multiplies by x to the power 1. So that means the derivative of the inner function is going to be 2x to the power 1. Because power 1 is the same as x in this specific instance, we're going to have 2x. So we need to multiply these two together. In a formal way, we're going to have 2x, with 2x coming at the front to make it neat, cos, and then leaving the inner function unchanged. And this is going to be our final answer. Now remember, this is cos. So for the multi-layer trap challenge, we have the problem y equals Euler's number to the power sin 3x. For this specific problem, we have a set of 3 boxes. We need to find the derivatives of each box and multiply with each other without making any changes to the functions within each box. The derivative of Euler's number to any power is that number. So for this reason, we're going to have Euler's number to the power sin 3x multiplied by the derivative of sin 3x, which is cos 3x, without making any changes to the inner function, multiplied by the derivative of the third and final box, which is going to be 3. To write it formally, we're going to have 3 multiplied by Euler's number to the power sin 3x multiplied by cos 3x. This is going to be our final number as the answer to our problem. And there you have it, folks. You have now mastered how to solve derivative problems involving composite functions for AP Calculus. If you did enjoy this video, remember to like, hit subscribe, and share with a friend or a loved one. I shall see you in the next video.